For this problem, we're going to determine how to find the moment of a force when it's rotated around a specific point in three-dimensional Cartesian form. And the basic way to do this is you want to find your position vector between the 2 points, and then you want to cross it with your force vector given this formula here. And we are given our force vector, so essentially all we need to do is just find our position vector and then cross it with this. So to find my position vector, I like to find the specific points of each of my points that are going to be in the vector. So starting with point P. Now in a typical three-dimensional Cartesian setup, x over here is going to be positive. Any y values over here is going to also be positive, and any z values going up is going to be positive. So you see point P, we're going to have a negative 2x value, a negative 3y value, and a positive 2z value. Now for point A, we're going to have a positive 3x value, a positive 3y value, and a negative z value of negative 1. Now to find the position vector, you want to subtract the tail from the head, so whatever your forward vector is. Now when you're rotating around a specific point, that point is always going to be your tail. So in this example, point P is going to be our tail, while point A is going to be our head. So for vector P, which is our tail, and then A, which is our head, I kind of like to line my 2 points up like this, so I know exactly how to subtract it without getting too confused. So for our x value, or our I hat, it's going to be a 3 minus a negative 2. Plus 3 minus a negative 3 here. And then for our last k value, be negative 1 minus 2. So that gives us a position vector of 5, 6 in the y direction, and then negative 3 in the z direction. And since this position vector represents distance, don't forget to add your units here, which is meters. Now that we have our position vector, we can go ahead and cross it with our given force vector here. So go ahead and get that set up. I, J, and then K. And always start with your position vector first. Always kind of remember as RF. So our position vector is here. So 5, 6, negative 3. And then our given force vector, which is 2, 4, negative 6. So it's going to be the moment vector around point P. It's equal to this. So how I do my cross products is I like to, especially if I'm writing on a piece of paper, I'll cover whatever segment I'm calculating up with a pencil. So as you can see, you start with the I section here. So I typically just cover this up. That tells me that I know I'm going to be calculating these 4 numbers for that first parentheses. So, and then after that, you just kind of work. You start at the bottom right here, and then you cross multiply with the top here, and then you subtract it by starting in this bottom number here, multiplying it with this upper right number here. So, you go here and then there, following this formula. So we'll go ahead and start with our I. So like I said, covering this up, I know that I'm going to have to multiply negative 6 times 6 and then subtract that by 4 times -3. That gives us our I vector. And then take note here in the formula for your J, there's a minus sign here, so don't forget about that. So we're going to subtract. And like what we did with the I hat, I typically cover this part up, and I know that I have to multiply this number, that number, and that number, and that one. So we're going to go ahead and do that. So -6 times 5, and then we're going to subtract it by 2 times -3. And then for the K value, let's go ahead and do it down here. As you can see in the formula, it's going to be a plus. So plus. Once again, I would just cover this up. Now I know to use these 4 numbers for my cross product. So starting with the 4, so it'll be 4 times 5. We're going to subtract that by 2 times 6. So going this way and that way. And that gives us our K value. So, and then we just use basic addition and subtraction to get our actual final moment vector around P. And our final answer is -24 I plus 24 J plus 8K. And since we're crossing 2 different vectors with different units, we're going to have to use both those units in our final answer. So it'll be kilonewton per meters. And that's pretty much it. So pretty straightforward. The main thing is just have an understanding of this cross product formula and being able to find your position vector with the 2 points. And then once you find that position vector, which is pretty straightforward, just the head minus the tail, then you'll be able to cross it with whatever force vector you have, and then you get your final moment.